Hello and welcome back to Ganesh Institute. So this is another section from complex analysis part, and that too we are taking up harmonic function. What are harmonic function after analytic function, and how can we create an analytic function using Milne Thomson method? So there are two things which we are going to do. Okay, let's begin. What is a harmonic function if I ask you? So basically there is a Laplace equation, and any function which satisfies it, that will be called as harmonic function. Okay, any function of the form fxy having continuous partial derivatives of first and second order which satisfy Laplace equation is called harmonic function. Now what is the Laplace equation if I ask you? Last time we studied about Cauchy-Riemann equation. Now another type of equation which is Laplace. It is the double partial derivative of f with respect to x. If you sum it up with the double partial derivative with respect to y, and if that summation gives you 0, then you will say that yes, this is the Laplace equation, and this function, if it is satisfying this Laplace equation, that function can be considered as harmonic. Okay, is it clear? So for harmonic function, these things have to be satisfied. Firstly, that function have to be continuous in its partial derivative order, and second is Laplace equation. If you have to find out harmonic conjugate, you know what is conjugate in complex numbers? Let's say if you have function in the form of u plus iota v, then its conjugate will be u minus iota v. That means you change the sign of imaginary part. If it is plus, it will become minus, and if it is minus in the question, the conjugate will be having plus sign. In harmonic conjugate of a function, you have a function already, let's say uxy. That function is a harmonic function because it is satisfying Laplace equation. Okay, but to become conjugate, apart from Laplace equation, it has to satisfy Cauchy-Riemann equation as well. So if the function is satisfying only Laplace, it is harmonic function. And if it is, this is function, and if it is satisfying both Laplace equation and Cauchy-Riemann equation, then it is harmonic conjugate. Is it clear? Now let's talk about Milne Thomson method as well, because the question is asked generally by combining both of these things. That firstly check whether the function is harmonic or harmonic conjugate, then create an analytic function as well using any of the methods. So we are using Milne Thomson method here. So what is Milne Thomson method? Let's say you have a function which is in the form of uxy. Okay, now firstly, to create an analytic function, you must have del u by del x, okay, and then del u by del y. That means single partial differentiation of u with respect to x and y respectively. And you have to name them. Let's say you are calling it phi1 with respect to xy, and this with respect to y is phi2. Okay, then your function, this is when the real part of u is given to you. You apply this method. Case 1, when real part is given to you, you will find del u by del x and del u by del y. You will name them as phi1 and phi2. Then the function which you want to create as an analytic function will be integration of phi1 with respect to z0 minus iota integration of phi2 with respect to z, and then of course constant. Okay, now what does it mean? I'll take up one example and make you understand. Now if another case is given to you in the question that imaginary part is given, let's say vxy is given. You have a function in which you have u plus iota v. This is real part, this is imaginary part. So if vxy is given to you, that is imaginary part is given to you, what you will find out? It will be quite similar, but you have to find out dv by dy first, then del v by del x, name them as phi1 and then phi2 at points x, y. Okay. Once you get these partial derivatives, then you have to find out the function similar to the above function, which will be integration of phi1. You have minus sign here, right? But in case of imaginary part, you will be having plus sign phi2 z comma 0 dz plus constant. Okay. So let's see how it will work in terms of one example. So here's the question. You have a function u, let's say e raised to power x cos y minus y sin y. You have to find out analytic function, you have to check whether it is harmonic or not, and then you have to check whether harmonic conjugate condition is satisfied. Okay, all these three parts will be covered in single question. So in order to create a function out of this, okay, in terms of complex number, to make an analytic function out of it, what is given to you? U. No iota is here. That means real part is given to you. So you will use Milne Thomson method, and using Milne Thomson method, firstly you will find out the partial derivatives, right? Just like I told you in previous slide. So firstly, let's say phi1, which is of course del u by del x. Okay, tell me what will be the differentiation of this bit. If you expand this, it will be x e raised to power x cos y minus e raised to power x y sin y, right? Okay, if you do with respect to x, what it will form? Cos y you will consider as constant. Just apply the product rule in x into e raised to power x, because we are doing partial derivatives. So firstly, derivative of x rest as it is, plus derivative of e raised to power x rest as it is. Partial derivatives done. Then here with respect to x, only one x component is here. So this will be your answer. Yes or no? So phi1 is derivative of x is 1. So here you get e raised to power x cos y. Derivative of e raised to power x is e raised to power x only. So here it is. Then minus e raised to power x y sin y. Okay? Is it fine? This is your phi1. You can take out e raised to power x common if you want. So it will give you e raised to power x cos y plus x cos y minus y sin y. Okay. Now for phi2, what do you want? Derivative of u with respect to y. Yes or no? So with respect to y, here is only cos y. So x e raised to power x will be as it is. Derivative of cos is minus sine. Minus, here you have two things. Firstly, y and then sin y. So I am keeping e raised to power x here. Now derivative of y with respect to y is 1. So sin y as it is, plus y as it is. For sin y it is cos y. Yes or no? Now if you expand, you will get what? minus x e raised to power x sin y minus e raised to power x sin y plus y cos y, which will become minus y cos y, and you can take e raised to power x common as well. Is it fine? I have taken up minus common, so here is minus and here is, it has to be plus, correct? Okay, now you have got phi 1 and phi 2, which is the prerequisite. So you have to apply Milne Thomson method, and what it is, phi 1, oh, it is not visible at all. Okay, phi 1 at z comma 0, then phi 2 at z comma 0. Okay, z comma 0 means instead of x you will use z, and instead of y you will use 0. So in place of phi 1, if I put y as 0, this will be 0 then. Only these two things will be left. Okay, put x as z and y as 0. Cos y is, cos 0 is 1 plus x cos 0 is, x is z, cos 0 is 1. This will be left, yes or no? Now for phi 2, if you put phi 2 z comma 0, so here instead of y you will place 0. So sine 0 will become 0, 0, 0. Everything is 0 here. So because real part is given, so Milne Thomson method states that the function will be the integration of phi 1 at z comma 0 with respect to z minus iota integration of phi 2 z comma 0 with respect to z plus constant. Yes or no? Now simply put here, this is 0, the whole thing is 0. Now you have to simply take the integration of phi 1. If you take integration of phi 1, let me change the color of the pen. Is it visible? No. If you take the integration of phi 1, what it will be? E raised to power z dz plus e raised to power z into z dz plus constant. Yes or no? Okay. Now tell me what you will get by integrating these. The function, of course, but what it will result into. Okay. So e raised to power z, integration of e raised to power z is e raised to power z only, correct? Now here you can apply parts by parts. You know what it is? Here is the acronym I late. In parts, if you have product of two functions, then you follow this order. I means inverse trigo, L is logarithmic function, algebraic function, trigonometric, and exponential. Exponential always comes last. So you will consider this as last function, this as first function. And the formula goes like first function as it is. So this is the first part, this one. Now I am considering this one. Okay, let me do it here only. First function as it is, second integration. So integration of e raised to power z is e raised to power z minus derivative of first function. Derivative of z is 1. Integration of second function, which is e raised to power z only, and then again integrate it. So it will give you z into e raised to power z minus e raised to power z plus constant. Yes or no? So this will be cancelled out. So function, the value of function is z into e raised to power z plus constant. If you like, you can substitute the value of z as u plus iota v. So this is how you can figure out how you can check particular function as harmonic using Laplace equation. How can you check whether the particular function is harmonic conjugate? By checking both of the conditions, Laplace as well as Cauchy-Riemann. And how can you find out an analytic function from a real or imaginary part? Using Milne Thomson method. Okay, let's see. Let's do one example of harmonic and harmonic conjugate as well. Let's say you are asked that this is the question where uxy is given to you as y plus e raised to power x cos y, and you have to find out the function fz, okay, using Milne Thomson method for real part, because of course real part is given to you, then you will apply that only. So what we do, we usually find out del u by del x first, correct, and that we will say that it is phi 1. Then we find out phi 2, which is del u by del y, correct. Okay, if you differentiate, partially differentiate with respect to x, what you will get? E raised to power x cos y, because y is constant, so its derivative will be 0 if you are doing with respect to x. Here, differentiation of e raised to power x is e raised to power x. For cos y, again it is 0, so it will remain as it is. Now for y, it will be differentiation of y is 1. Here e raised to power x will be constant, and for cos y you will be having minus sin y. Yes or no? So let me write minus sin y. Correct? Now you have to find out phi 1 at z comma 0 in order to use Milne Thomson. So you will put z in place of x, so e raised to power z, and in place of y you will put 0, so cos y is cos 0, which is 1. Here again you will find out phi 2 at z comma 0, so it will give you what? Phi 2 at z comma 0, it is x, so minus e raised to power what? Z, then y is 0. Y 0 means sine 0, that is 0. So phi 2 will be 0 only, correct? Yes or no? E raised to power z, 1, derivative of y you got 1 minus e raised to power x sine y, correct? So here it is. Just bear with me. So 1 is here minus this is 0, that is 1, correct? So you've got phi 1 and phi 2. So what your function is now? Fz. Using Milne Thomson, what it is? Integration of phi 1 at z comma 0 dz minus iota integration of phi 2 at z comma 0 dz plus constant, let's say c. So your function becomes, this is phi 1, which is e raised to power z. If you integrate it with respect to z, you will get e raised to power z only, right? If you substitute phi 2 as 1, so integration of 1 with respect to z will give you z, so minus iota z plus c. This is your function. So first part is done. Okay, now if you have to check whether the function is a harmonic conjugate or not, you have to satisfy two equations, right? One is Laplace equation, second is harmonic Cauchy-Riemann equation, correct? So can I substitute z as x plus iota y, right? So what it will give you? Function will become, in terms of x plus iota y, it will be e raised to power x plus iota y. Here in place of z, just substitute x plus iota y plus c, correct? Now because I am substituting fixed values, so just forget about c at the moment. It will be equivalent to e raised to power x into e raised to power iota y minus iota x minus iota square y. I simply expanded it, correct? So e raised to power x, e raised to power iota y minus iota x, and we know iota square is minus 1, so minus minus plus 1, right? Now you know what is e raised to power iota y? according to Euler? It is cis, cos plus iota sine. Correct? Cos y plus iota sine y. So can you substitute here? Function is e raised to power x cos y plus iota sine y. Okay, I have substituted here the value of e raised to power iota y. Rest everything is same, iota x plus y. Correct? Now can you expand it? E raised to power x cos y plus iota e raised to power x sine y minus iota x plus y. Correct? Now what is real part here? This one. So u is e raised to power x cos y plus y. What is imaginary part here? V, which is iota, you can take common. What is left? E raised to power x sine y minus x. Yes or no? Okay, so if I have to create u minus iota v form, because ultimately this is the part. If real part is given, we form this phi 1 minus iota phi 2, right? So u minus iota v, harmonic for harmonic conjugate, e raised to power x cos y minus iota, so sign will be changed here, x minus e raised to power x sine y. Yes or no? Is it fine? Now in order to check whether it is harmonic function, whether it is harmonic conjugate function, we have to find out Laplace equation and then Cauchy-Riemann equation. Yes or no? So let's figure out. Okay, what is a Laplace equation? Can anybody tell me? Yes, double derivative of that particular function, right? With respect to x, with respect to y, has to be 0. This is the Laplace equation. And how can you find out Cauchy-Riemann? Ux. What is ux? That is del u by del x, which we have already found out, e raised to power x cos y. What is vx? See, this is v function, this is the part. If you have to differentiate it with respect to x only, you will get e raised to power x sine y is constant minus 1. Yes or no? What is uy? Uy, if you have to do it with respect to y, it is, we have already found out, 1 minus e raised to power x sine y. What is vy? Differentiate it with respect to y. So e raised to power x, for sine y it is cos y, and x is 0 because we are doing it with respect to y. Correct? Now tell me, is ux equal to vy? Yes. Is uy equals to minus vx? Yes. So can we, this is v, can we say that Cauchy-Riemann equations are satisfied? Yes or no? Correct? If you do double differentiation of this, Cauchy-Riemann satisfied? Now about Laplace equation, this has to be satisfied, and you will find that it is giving you 0. How? Let's see. Double differentiation of this is with respect to x, e raised to power x cos y. Yes or no? Double differentiation of this part, del u by del y, with respect to y. 1, derivative of 1 is 0, minus e raised to power x, for sine y it is cos y. If you add these two, it will give you 0. So Laplace equation is satisfied. Because both of the equations are satisfied, so we can say that this function is harmonic conjugate. Yes or no? This is how you can find out a particular question. Let's take up another one as well. So let's say if you have a question where uxy is equals to y plus e raised to power x cos y. Okay, this is the question. If u is this, and you have to check whether the function is harmonic or not. See, this is polynomial function, this is exponential, and this is trigonometric with sine and cos in it. So it is continuous function, right? Because it is made up of combination of continuous functions. Now we have to check if it is satisfying Laplace equation or not, because then it will be declared harmonic if it is satisfying. Laplace equation is what? Double differentiation of u with respect to x, double differentiation of u with respect to y, and it has to be 0. Okay, so firstly single derivative. With respect to x, so y will be considered what? Constant. Now here apply product rule, but for cos y we have constant thing. So e raised to power x, derivative of e raised to power x is e raised to power x, cos y is constant here, right? Now similarly, if you find out del u by del y, now you will consider x as constant. So derivative of y is 1 plus x is constant, derivative of cos y is minus sin y. Okay? So it is 1 minus e raised to power x sin y. Now again differentiate with respect to x. So e raised to power x, derivative of e raised to power x is e raised to power x only. Y is constant, so keep it as it is. Again differentiate with respect to y. So this will give you 0. Derivative of sin y is cos y. Minus is already there. Now if you add these two, tell me what you will get. Both will be cancelled out, you will get 0. Because it is satisfying Laplace equation, so it is harmonic function for sure. Okay? Now, to check it a bit further whether it is harmonic conjugate or not, two things have to be satisfied. One is Laplace equation, which we have already satisfied because it is a harmonic function. So it is giving summation 0. Now, Cauchy-Riemann. What Cauchy-Riemann states? So ux has to be equal to vy, correct? And uy is equals to minus vx. Okay? Are we given with vy and vx here? No. So we have to find out vy and vx using Milne Thomson method. Once you find out using Milne Thomson method that analytic function, and then you have to apply. If Cauchy-Riemann equations are satisfied, then you can say that this function is harmonic conjugate, otherwise it is not. Is it fine? Hope you have understood this question, and if so, then don't forget to like, share and subscribe my channel. Till my next video, take care of yourself. Bye bye.